record. And let's go to whiteboards. Hopefully you guys can see my whiteboard, yes?
It's telling us updating on our end.
Can you see it?
It says update. Updating.
There it goes. There we are.
Loading your whiteboard.
Okay,
Yep.
OTDR.
OTDR. Yep.
Okay, that's our first topic, and our second topic is going to be research.
No.
All right, so let's go ahead and start with OTDR, which stands for optical time domain reflectometer. OTDR. All right, what does all that mean? I've written it in 3 lines, and the reason I've done that is because we can kind of break it down to the components of its part. When we talk about optical, what are we talking about?
Light.
Light. Time domain, what does that mean? It means that we're measuring time. And reflectometer, see, the meter part has to do with the time part. So we're measuring time and we're measuring the reflection. That's what's taken out of this. So let's take light, time, and reflection. Okay, if I take a light and pulse it right here and send it over to a mirror, and then bounce it back, remember, according to Snell's law, can either reflect or refract, and measure the time it takes to get there and back, we can use that to determine the distance. Have you seen this before?
No.
Anybody ever seen anything like this before?
Start with the ultrasonic sensor. Not with light. We do
So
it
in your Arduino, you have this thing, right? Which is what you were talking about.
Yeah, ultrasonic sensor. Yeah.
Oh yeah, the distance of when it goes out and back.
Mm-hmm.
I'm just.
So we send out a pulse of sound, we measure, and you guys have all written an Arduino program to do that, I believe, at some point, correct?
Yes.
Mm-hmm.
So you understand the process of how this is done. We send out a pulse and we start counting time until the pulse returns.
Mm-hmm.
This is a troubleshooting device for fiber optics. Okay, so I'm going to erase what I have, if you don't mind, and start afresh. Any questions on what we've talked about so far?
Nope.
It's nothing like having a tiny little eraser. I'm sure there's a way to make it bigger, but I don't want to get rid of the whole screen.
At least your markers work.
Yeah, exactly. That is a good point. All right, so here we have. Now you may think this is a waveform, but it isn't. What it really is the ocean. USA and somewhere else. And what we're going to do is we're going to take and drag a cable down on the ocean floor all the way across from point A to point B. And that is going to be a fiber cable. Okay, good so far?
Yeah.
All right. Oops, earthquake. Oop, the cable broke. And this is like, I don't know, 6,000 miles. How do we find where the break in the cable is so that we can send a ship out there and fix it? So you know there's a break somewhere. You don't know where it is. How are you going to find it?
Taking the new OTDR and subtracting it from the original.
So when we look at that break underneath, if we look at that break, which looks like this, you know, my drawing just plain sucks, but it looks like this. But if we take and blow that up, what we actually have is a boundary.
And will that act as a mirror and reflect it?
It will act as, I wouldn't say it will act as a mirror, but it will cause some of the light to reflect.
Okay.
Okay, so it'll hit that break, and a portion of it will reflect. So if we send that out, again, we can measure delta T, how long it takes for the light to get to the break and reflect back to our OTDR, which is over here. Sends out a signal, does exactly what your Arduino does over here, sends out a signal, waits for the response, and then gives you an idea of how many meters the break is from where your OTDR is. Okay, the thing about OTDRs is they are pretty darn expensive. So typically it's not going to be something that you're going to have yourself. For a good one, you're going to pay thousands of dollars for it. So typically that's going to be something that's going to check out from, you know, from the tool shed or borrow, or your company's going to own something like that if you're working in fiber optics. But that is one of the ways that we can troubleshoot a fiber optic cable, especially when it breaks. And that's normally the main thing that goes wrong with them, is there ends up being a break. Okay, so OTDR troubleshooting. Any questions on what we're talking about? No response. I assume there are no questions, and we'll move on to the next topic.
Yeah. Interesting.
Okay, let's talk about this. I think we may have already had this discussion.
Nope. Oh. Oh, about what a technical brief is.
Research paper versus a technical brief.
That would be-
Okay, I think we may have had this conversation when you did the FET comparison thing some time back. We talked about research papers being full of a bunch of crap that I don't need to read. They're usually assigned by a number of words or page length. Not interested in that. Just like we said, just the facts. It's funny. I just had the 109 lecture with those guys today doing this assignment, and we had just these words down about just the fact. So here's what I would like to see. We've talked about 3 different ways to move information. We've talked about wire. We've talked about air. And we are now talking about fiber, which is really plastic or glass. 3 different ways to get information from point A to point B. This is what I would like you to provide me with. Number 1, a comparison of transmission reception tech or practices. How do we transmit and how do we receive on these different things? Relative advantages and disadvantages. And 3, which is usually the most important, how do you pick which one to use? Okay, so how are these things compared technically? What are the relative advantages and disadvantages of each as a medium? And how do you determine which of those media you wish to use? Okay.
When does it due?
It is due on July 10th. That is a Wednesday. And just so you know, I will be out July 8th and July 9th, which is Monday and Tuesday of that week. I will not be in the office. I will not even be in the neighborhood. I will be in Eastern Washington for those 2 days. It's semi-work related. I'm doing some industrial training.
Okay. And we won't be here the 4th or the 5th either.
Yeah, so you'll have plenty of time to get this done. All right, so that pretty much lays out what we were going to do today. Does anybody have any questions? And again, I did record this, so I will be posting it as soon as I can. I did get the last one posted finally. So I had some trouble doing the closed captioning for some reason. I'm worried about it this time as well because it wouldn't pick up the questions, and I had to edit the heck out of it in order to get it to make any sense. So I'm hoping that this will pick up whatever comments or questions from the peanut gallery. But we shall see. So again, anyone have any questions? Otherwise, for the good of the order, I'm going to put a cap on today's activities.
Thursday, we do have a lecture though, again, right? 11?
I believe so. I don't remember. I don't have that in front of me, but it's on the Canvas thing.
You said
It looked like it was about research assignment.
Research
On
assignment, so I don't know if it means we're gonna work on our research assignment.
Are we gonna talk about our research assignment?
Okay, like did you not hear what I just said? I don't have it in front of me. Hold on just a second and let me see if I can find that information because I don't remember what I typed. Hold on. But it, but it, dum, dee, and of course, I don't have that up here. You're gonna have to look at the Canvas class, whatever it says. I may have just given you the day to work on it.
It says fiber optic Zoom research assignment. That's all it says, so.
Okay, then that's for Thursday.
Correct.
Yeah, so Thursday we will talk about a little bit about the Christ comparison.
Okay,
So I'll give you some more information on Thursday about that. That will be optional for you guys. If you guys want to come, great. I'm not going to cover any really new material. I'm just going to talk about the relative weights and advantages of that, and then you'll have to put it together in some kind of cohesive manner.
okay, excellent.
All right, so it'll be optional. It'll be there. I'll see you at what time is that? 11 o'clock then?
Yes.
Yeah, wonderful. All right, anything else?
We could do it earlier since you're not doing anything else with the other classes.
Do you want to do it, what, at 10 o'clock? Are you sure I'm not doing it? Yeah, we could do it at 10 o'clock if you want.
Raj?
Okay,
Yeah.
all right.
Robert,
Yes,
do we have PLC tomorrow?
we can do that tomorrow
Yes.
if you'd like, yeah. What time? What
Okay.
time?
Good deal. We'll do a lecture tomorrow and I'll record it for Melissa.
Sweet, yeah, I made good headway on those things. I got a bunch of the modules and stuff done, so.
Good, then we don't have to worry too much about programming as much as we can look at hardware.
All right, sounds good.
It's scheduled for 11 as well. You want it earlier?
Yeah, if you can do it, if we wanna do it at
It's
10,
on
we
my
can do it at
side.
10 tomorrow.
Yeah, if I don't have anything else scheduled.
It says no lecture, that they're gonna work on their labs and research.
All right.
Yep. Okay, so we can move both of those to 10 o'clock.
Yeah.
Okay,
Yeah.
excellent. Thank you,
All
sir.
right, sounds good.
Right.